There's something about this that allowed me to rideshare with him. And it's the fact that I could see him in person and I thought he was trustworthy and we had similar interests. However, this is not the case for a majority of other rideshare systems. For example, a massive impediment on ubiquitous ride sharing is the factor of trust. You don't know who you're going with and you don't know who is going to be driving you. And these type of factors make drastically inefficient and people less willing to rideshare. So we propose a system of ride sharing that allows people, co-passengers, to link through social media. And it's found in many related works that trust is a major factor in whether people ride with each other. So with the current method, generally people have about 1.6 persons per vehicular mile, which is actually drastically inefficient. It increases energy consumption, increases emissions, and also just overall decreases efficiency. So to address this problem, we identify three crucial components that affect trust between co-passengers. And with these three measures, we have built a trust model that can improve the F measure to 87.4%, an improvement from 78.6 from all of the previous factors collected. So to start off, we collected ground truth data. So from January 20th, 2017, we started with a single public seed, which is University of North Texas, UNT, which is where the research is conducted, as seen by the emblem. And what we did was that we started with the followers of this public seed. It started with 27,000 followers. From there, we could not access the private accounts, so we filtered the private accounts. And now we were left with 8,436 profiles. We performed a simple random sample and obtained 100 users. And we obtained three general categories of information. So we obtained the user account information, the post information, as well as the user information. So for user account information, it includes followers, followings, and posts. And specifically about the post, you can have total number of likes, total number of comments, create time caption, hashtag. And for the user information, you can obtain the username, and the full name and biography are optional. And for these, we use the platform of Instagram as our data set. So here we can see, as an example of what you can actually obtain from this search query, you can see the username, total number of posts, total number of followers, following. That was an example of the first name, location, and in this case, we selected 10 of the most recently posted pictures from each profile. As for the factors that we decided that would influence trust, would be the following, followers, posts, likes, and comments. And from there, we found the total number of likes and total number of comments for each post. So from selecting these factors, we also put three key picture attributes. So total number of people among the 10 photos, the total number of pictures that contained a person, and the total number of person that contained the user. So to continue with to gather our ground truth data, we used Amazon's Mechanical Turk, and for each profile, we actually used 5 Mechanical Turks to take a survey, and we provided them with 10 of the latest posts. They contain detailed information, for example, captions, number of likes, number of comments, and the location of the post. So with this information, they were given this survey. So the survey question 1, if this person were a driver for a rideshare service like Uber, I would trust this person to give me a ride. Question 2, if this person were a driver for a ride service like Uber, I would trust putting a close friend in a car with them. Question 3, riding with this person would be more risky or less risky than average. Question 4, during the ride, I would probably talk to this person more than average or less than average. And question 5, if this person was assigned to me as a rideshare partner, I'd feel safe riding with them in a car. And finally, if you find out this person will be your rideshare partner, how likely are you to use the ride service? So something to know about these questions, while they seem rather similar, one of our co-authors is a communication studies professor, and he helped us come up with these questions in order to assess the multiple dimensions of trust and different aspects of trust. And with all these questions, it gives a finer granularity on like the degree of trust. So from this survey, our Mechanical Turks came up with these results here. So from this, you can see that the top 3 rows would be considered, those are the amount of profiles that are not trusted for each individual question. And now that we have obtained the ground truth data, we do a little bit of factor analysis. So we use a 5-step exploratory factor analysis. So first, we evaluate the data to see if it's suitable for factor analysis. Then we extract the factors to see if the principal components can explain for the variance of the factors. And then we do a factor retention to see the amount of factors that we must take. And then we rotate it. We do a Varimax rotation to find the principal components. And then we interpret and label the principal components. So let's start with evaluation of data suitability. So we used KMO and Bartlett's test to analyze if the data set was suitable for a factor analysis. And what's generally considered suitable is 0.6 to 0.7. In our case, it was 0.714. So this would conclude that our data is, in fact, good for factor analysis. From there, we extract the factors. So we use principal components method. And from there, you can see that of the 8 factors that we have selected, that the principal components can explain for roughly 80% of the variance, which is indicating that it has a strong explanatory value. And through this, we then go on to factor retention. So we use 2 methods to check how many principal components that we take. So first, we use Kaiser's criteria. So anything above the eigenvalue of 1, we would consider a principal component. So in this case, as you can see in components 1, 2, and 3, the total eigenvalue is above 1. And if you look at the cumulative percent of variance explanation, you can see that it accounts for about 86% of the variance. And what's generally considered in humanities, it's generally considered between 50 and 60% is considered suitable. So in our case, it would explain up to 86% of the variance. So our second method to find factor retentions, we just plot it on a graph and on a scree plot, and then find the steepest parts of the graph. So we extract 3 principal components. And from there, we use these principal components and we apply a Varimax rotation to the 8 factors. So what this essentially does is it maximizes the high loadings and minimizes the low loadings, which really accentuates the categories and the pertinence of each factor in the principal components. So in the highlighted sections, you can see the maximized high loadings and how it works. So from there, we categorized these 3 sections, these 3 highlighted sections, into 3 concise components. So that includes social proof, social approval, and user self-disclosure. So social proof represents like the positive influence that you show. Is essentially what you provide to other people. So any proof that you are more social, more likable, for example, pictures of you, pictures of people, and especially pictures of like people with large groups would generally be considered more trustworthy. From there, this social proof actually can account for 40% of the variance. So going down the list, social approval, on the other hand, is expressed through what other people think of you. So essentially the total amount of likes and the total number of comments. So from there, it's what other people perceive. This accounts for 33% of the variance. And user self-disclosure is how active you are on your social media profile. So in the case that you follow more people or that you post more, it's generally correlated with a higher trust value. But in this case, it explains 13% of the variance. We continue with a logistic regression, comparing the two graphs. The first table 10 being the upper graph or table is what would be predicted if you used all 8 factors, and the F measure is in the low 0.7s. And if you look at the F measure after we combine them and use principal components method, we actually have a significant increase in F measure. So we plot this on a graph, and as you can see, the orange bar generally is over that of the blue bar in precision, recall, and as well as F measure. So as a brief conclusion, if you want to manipulate your trust value or how much people trust you, there's three main components that could influence this. And I'm not saying to try this, but I don't know, it's a possibility. So the first one you have to count for is social proof. So this one's actually, you just have to be less lonely, I guess. You take pictures of yourself and take pictures of your friends a lot more often, and this will cause general increase in trust. So that would be the greatest factor that you could probably manipulate. The second one would be social proof. This one's a bit harder to manipulate in this case, so let me go back to this. Social proof is a little bit harder to manipulate because this is what other people think of you as. So in the case of social approval, you could have friends and ask them to like your pictures, or two, you can create a bunch of other Instagram accounts to like your pictures. So if you want to be weird. Anyways, user self-disclosure is just to be more active, to follow more people, and to post more, would generally be considered a more trustworthy person. So using our proposed rideshare method, connecting through social media, these are the three key factors in trust prediction. So, ta-da!